guys, Physics in the Flesh is back. Let's do a problem involving work with varying force. The force on an object acting along the x-axis varies as shown in the graph below. Determine the work done by this force to move the object A from x equals 0.0 to x equals 10.0 meters, and B from x equals 0.0 to x equals 15.0 meters. Okay, so this is the graph that we have in this problem. On the y-axis, we've got the force in the x direction measured in newtons, and in the x direction, we've got the distance in meters. Okay, so you can see that in the positive x direction, our force is increasing for a certain amount of time, stays constant, decreases, starts going in the opposite x direction, stays constant in that opposite x direction, and then starts decreasing again back to zero. Okay, so here we're looking for work. Okay, so think back to our formula for work. Work is equal to force times displacement, right? Of course, times cosine of theta. But here, right, our force is in the x direction and our displacement's in the x direction. They're in the same direction. Therefore, theta is equal to 0. So that cos theta that you have there, the cosine of 0 is equal to 1. Right? So that disappears. That becomes 1. So work is force times displacement. Now consider this for a moment. Imagine you had a rectangle, and that rectangle had width delta d and height f. How would you find the area of that rectangle? Well, the area of that rectangle would just be length times width, right? Or f times delta d. And that just happens to be the formula for work. So essentially what I'm saying is when you have a force versus distance graph, the area under the graph is the work done. Okay, so for example, for A, from x equals 0 to x equals 10, that's right here above the x-axis. To find the work done, we're going to find the area of this entire trapezoid here. Now, instead of just calculating the area of a trapezoid, we're going to break this up into simpler shapes. Okay, so I'm going to take this point, drop it down to the x-axis, take this point, drop it down to the x-axis, and I'm going to break this big shape up into 3 components, 1, 2, and 3. So, therefore, for part A, from x equals 0.0 meters to x is equal to 10.0 meters, to find the total work done, essentially what we're doing is finding the total work, or the total area of parts 1, 2, and 3. So I'll call it W1, 2, 3. That's going to be the total area, which is going to be area 1 plus area 2 plus area 3. Now the nice thing about here is that you see the base of triangles 1 and 3. The base is 3 and 3, and the heights are 400 and 400. So instead of adding A1 and A3, you can just double A1 and you'll get the same result. So 2A1 plus A2. Okay, now A1 is a triangle, so we know that the formula for the area of a triangle is 1/2 the base times the height. The base is 3, the height is 400. And just to be sure our units are fine, we have meters and newtons, so we don't need to do any conversions. Okay, so there's A1. A2, it's a rectangle, so it's just base times height. So the base is 1, 2, 3, 4, 4 by 400. So plus 4 by 400. So honestly, it's just a simple multiplication and then addition. Okay, so these twos cancel out, and then you get 3 times 400 plus 4 times 400. You end up with 2,800. Okay, we want to round that, or at least express it in proper notation. Let's do it in scientific. 2.8 times 10 to the 3 joules. That is the total work done for 1, 2, and 3. So that's the answer for part A. So hopefully that was okay. Now, you do understand that you can have negative work as well. Check out this formula, FD cos theta. We know that the graph of cos theta looks something like this. And at a certain point, the graph of cos theta becomes negative. Okay, so negative work just means your force is opposing your displacement. Okay, so they're going in opposite directions. And if you take a look at the graph here, although your displacement's positive, your force is negative. So we're going to call that negative work. Okay, and it could just very well be that they're going in opposite directions. Okay, so nonetheless, let's go ahead and calculate that. So for part B, we want from 0 to 15. So we already found this portion. Now we have to find this portion. And I'm going to go ahead and break this up into pieces as well. Okay, so I'm going to call this triangle 4, this rectangle 5, and this other triangle 6. Now, I can't simplify this like I did this one. In this first part, the two triangles 1 and 3 were the same. 4 and 6 are not. The base of 4 is 2 meters. The base of 6 is 1. So it's not a big deal, though. Okay, so let's do part B over here. So this is x equals 0.0 to x is equal to 15. So first things first, let's do this, and then we'll add these two together, okay? So the work for 4, 5, and 6 is equal to A4 plus A5 plus A6. Okay, so A4 is a triangle, 1/2 the base, which is 2, times the height, negative 200, plus A5, which is a rectangle, so base times height, so 2 times minus 200, plus the last triangle, number 6, 1/2 the base, which is 1, times the height, minus 200, and honestly, you just plug it in, okay? So, for example, this first part right here, you're going to get minus 200 because these twos cancel. Here you're going to get minus 400. And here you're going to get minus, well, actually, no, not 400. The 2 cancels with that, making that a 100. So that's actually going to be minus 100. Okay, so there you go. So we do minus 200, minus 400, minus 100, and you get the work from 4, 5, and 6 is equal to minus 700 joules. Okay, so far so good. Now, to answer part B, we have to add these two numbers together. Okay, so let's do that here. The total work is equal to work 1, 2, 3 plus work 4, 5, 6. So 2.8 times 10 to the 3 joules plus negative 700 joules. Add those two together. It's not going to make a big difference in the number, but here you go. 2.1 times 10 to the 3 joules. And that is the total work done from 0 to 15 meters. Okay, so there you guys have it. I hope you guys enjoyed the video. If you did, be sure to smash that like button. I realize all the endings of my videos sound the same, but hey, what can I do? Subscribe to Physics in the Flesh so you never miss a video from me. And stay tuned next time for the video 100, work with varying force 2. Guys, please be sure to tell your friends if they need help with physics or if they just need someone to subscribe to. All right, guys, I'll talk to you later.